So section 6.4 now takes a step further from parallelograms and talks about rectangles. We've all seen rectangles before. They have 4 right angles, and they're actually a parallelogram because the opposite sides are congruent, the opposite sides are parallel. But they have 4 right angles. That's the new key property. And then there's one extra to go with that. So if rectangle, then 4 right angles. If rectangle, then diagonals are congruent. The 2 diagonals are actually the same distance because of the right angles. So in rectangle RSTU, RT, this diagonal is 5x minus 7, and US, this diagonal, is 2x plus 2. We just wrote that diagonals were congruent, so I'm going to set 5x minus 7, set it equal to 2x plus 2. When I solve for x, I get 3x equals 9, so we get x is 3. The question is asking for UZ though. UZ, keep in mind, is half of a diagonal. So I'm going to find the length of a diagonal and then divide by 2. So when I plug 3 in, 2 times 3 is 6, plus 2 is 8. So US equals 8, which means UZ, that's not a U, UZ equals 4. So now we have this rectangle, and we know angle 1 is 37. We want to find all the other angles. Now I know this is a right angle, so 90 minus 37 gives me 53. Also, because these lines are parallel, 1 and 4 are alternate interior angles, making this one also 37. Now, because this is 37, and this is 53, and we know this is 90, we're able to find that since the diagonals bisect each other, these are isosceles triangles, making angle 3 also 37. When we look at that bottom triangle that has angles 3, 4, and 6, we know that it adds up to 180 degrees. So 180 minus 37 minus 37 gets at angle 6 is 106. Angle 6 and 7 are a linear pair. 180 minus 106 gets me 74. And now this is also an isosceles triangle, and I can go through the work. But angle 5 is the same as angle 2, 53 degrees. If you look at it, what we're going to get is this angle up here. There's 4 angles that are congruent, and then there's 4 other angles that are congruent, and I'm going to shade them with different colors. The ones shaded with that little black squiggle and the ones shaded with the little purple squiggle are all congruent. And then we know these angles are congruent. Now let's take a look at this. You saw this in section 6.3 where we use this top part to see if it's a parallelogram. We're going to use the second row to see if it's a rectangle, because if consecutive sides are perpendicular, that means they form right angles. If this says not a parallelogram, you don't even have to try rectangle, because if it's not a parallelogram, there's no way that it's a rectangle. That's B, -2, 4 is G, H is 1, -2, and L is -1, -3. So, trace it just so we can see it. Now, it looks like a rectangle, but we still have to go through and just double check to make sure. When I go through, are the opposite sides parallel? Okay, this one is up 1 over 2, so that slope is 1/2. Up 1 and over 2, this is also 1/2. It's a good start. Over here, up 1, 2, 3, 4, 5, 6, to the left 1, 2, 3. So up 6 over 3 means that slope is -2. And then over here, down 1, 2, 3, 4, 5, 6, over 1, 2, 3. Same slope, Opposite sides are parallel, which means this is a parallelogram. Now we're going to investigate further, see what type of parallelogram. Is it a rectangle? Is 1/2 and -2 perpendicular? They are opposite reciprocals. The opposite reciprocals all the way around, which means this is a rectangle. Because the opposite sides are parallel and the sides touching are opposite reciprocals, that's what makes it a rectangle.